Hello viewers, welcome to TSAT program organized by Government of Telangana, Commissioner and Director of School Education and State Council of Educational Research and Training. Today we are going to discuss about some of the concepts from class 10th. In class 10th we have different areas like geometry, algebra, numbers. Today we are going to mainly focus on geometry. Why geometry is more important? What are the different chapters that we find in geometry? In what way we can understand the geometrical concepts in a more easier way? These are the things which we are going to discuss today. Actually in geometry we can see that mainly we have similar triangles, tangents and secants to circles, and of course a little bit slight extension is like mensuration. So we have to discuss the key concepts of similar triangles. What are the key concepts of similar triangles? Just look at the screen. We have similar figures, and then we have to talk about similar polygons, and afterwards we discuss similar triangles and what is basic proportionality theorem, and what are the criterion for similarity of triangles. Of course we have different criterion like AAA, SAS and so on, and then further we discuss about areas of similar triangles and in what way Pythagoras theorem is proved and what are its applications. These are the different concepts we have related to similar triangles. Now to discuss these concepts in our studio we have some of the experts. To my left, the first person is Mr. 𝗳𝗧𝗊𝗁. He is guested headmaster in 𝗬𝗏 High School, one of the great expert in mathematics. And next to him is Mr. Padala Suresh Kumar. He is also a guested headmaster working in Nalgonda, and he is a textbook writer as well as subject expert. And to his left is Mr. 𝗂𝗽𝗍𝗫𝗀𝗏, textbook writer as well as faculty of SCERT, an eminent mathematician. Okay, welcome sir, welcome to the studio. So sir, what are similar figures? Sridhar sir, can you brief about similar figures?
Yeah, good. So in nature we are observing so many figures, so many objects. We can find some figures up on those planes. So we can say that a figure is a two-dimensional figure. That means we can find a two-dimensional figure from 3D objects which we can we have in our surroundings. So similar figures means to look the figures will be same but not in size, but may not be in size. So similarity means whichever the sides and the measurements of the sides or measurements of the angles or measurements of the total closed figure should be similar, then those figures can be looked as a similar figures. Just we can see that one leaf of a neem tree. So those neem leaves look like a similar in a shape. Or look at some other, we can see that triangle board on roads when we are traveling. So all triangles are look like a similar or not when the sides, the angles should be in same ratio or same look like in same figure. We can say that those are simply similar figures. So how we can decide those are similar figures and those are congruent figures, we can discuss it.
Yeah, fantastic sir. Actually simply speaking, similar figures means having same shape but not necessarily of same size.
Yes.
So actually what is the basic idea in this? If we observe, it is just a comparison. Children, you know well how to compare. You are very much familiar with the comparison of numbers. Like we compare numbers, like what are the possibilities we can talk about, like law of trichotomy. That is, whenever we consider any two real numbers, what are the possibilities? If we consider A and B like real numbers, A is equal to B, A greater than B, A less than B. if such kind of comparison, if we apply for the geometrical figures, what is the difference actually? Like we can see that in case of geometrical figures, we have measurements like sides and angles. So, how are we going to compare? That is the idea of similarity. And if you observe, like in case of equality, there here we have congruency. Like greater than and less than symbols, here we have enlarged and diminished or reduced figures. But the question is, do we see such a type of similar figures in our day to day life anywhere? Is it possible? Did you come across? Just think of it. Sir, before going to discuss about these similar figures, in what way this geometry is helpful for the children? Actually, in day to day life, they see several objects or the things which are congruent, which are similar. They will see in what way it is applicable in daily life situation. Where do they observe them?
One thing is, we can observing so many photos.
Yeah.
We have passport size photo,
Yes.
or a letter size photo, or a flexi or something.
Okay.
So, whenever we can enlarge the photo according to the sides, then same ratio, that will be look like same.
Yes.
If it is not in the same ratio of sides or angles, it look like a somewhat that will be thin, or the face will be longer than the real image, like that.
Yes.
So, those are not similar.
Yes.
Why? Because in circles also we can see circle. So, small circle, and we are going to enlarge the circle with the radius, it look like a similar figures. But whenever we are observing photos, so we are observing on the screen how they are extracted, how they are enlarged.
Yeah.
So, that will be the simple observation of the similarity.
Okay. In what way we can understand that? Okay. Can you give a few more examples from daily life about congruent figures and similar figures, Suresh sir?
Yeah. So, actually congruency means here identically equal. So, when you take those figures, so if they are superimposed completely, there is no, then simply we call it as congruent figures. So, we can say the figures which have same size and same shape.
Fantastic.
Both, then definitely we can say congruent figures.
Okay.
Here a very good question is congruency, similarity actually interrelated.
Yes.
So, all congruent figures are similar figures, but all similar figures need not to be congruent.
Fantastic.
So, this is a very important. So, as a teacher we have to explain the difference and relation between the congruency and similarity, then children can understand. Otherwise, you may get confused.
Okay. So, briefly speaking, we can understand that it is all about talking about shape, size.
Yes.
Okay. When the shape and size both are same, then they are congruent figures. When the shapes are same, but size may differ, then in that situation we can say they are similar figures. And truly speaking, congruency is one of the similarities.
Yes.
One of the similarities, it is not a separate one.
Yeah.
So, in a particular situation where sizes are equal, that particular situation of similarity we call congruency. We are giving a separate name for it. Okay. On the other hand, the figures, the size differ. If the image is larger, we call it enlarged figures. The image is smaller, we call them diminished or reduced figures. Like we can see in our day to day life, we come across Xerox. You can see enlarged Xerox. Whenever we need enlarged copies, we go for a Xerox shop and we take. Means noticeably, knowingly or unknowingly, we are using the concept of similarity, we are using the concept of congruency. Or otherwise, if you go to any market, like where suppose if you go near Charminar, you want to buy a Charminar model, it is a replica, it is a similar figure. The size is reduced to the great extent. Or even you can see when you are observing the maps in your textbooks, what about them? They are also similar figures, only they are drawn to some scale. So, similarity concept knowingly or unknowingly we are using in our day to day life. And congruent figures also we will observe. Suppose if you consider a TSAT cups, all are congruent. So, in general we are saying that similar figures we understood. Then what about similar polygons? in what way we can define similar polygons? Sir, Sharma garu.
Well, similar polygons as per the definition of the similar figures.
Okay.
In general, polygons which are of the same size, polygons which are of the same shape are said to be similar polygons.
Okay.
And triangle is in fact one
of the
part of the polygon actually.
Yeah.
And as Suresh sir and other experts said, the similar figures need not have same size. The sizes may be different, as you said, rightly given the example of the models, particularly the Charminar model or the Taj Mahal model. They have the sides are in proportion only, but they are not exactly same. Okay. And they are actually called as replicas. So, we have similar polygons, similar figures which are of having the same shape, but size may be different.
Okay. While coming to polygons, in what way we can go for the definition of similar polygons? Actually, similar figures, when we say, we just in general talk about shape, size. While coming to polygons, what makes the difference is, here we talk about in terms of sides and in terms of angles. Okay. Now, in general, in your textbooks you might have read the definition like the polygons which are having the same shape, but they may say a different size, means their corresponding angles must be equal and corresponding sides must be proportional. Here one thing we have to understand, the basic idea behind that is, if we consider the similar polygons, actually earlier we gave the definition of similar polygons like shape and size. Now all of a sudden we are talking about sides and angles. In what way we can understand that? Here the link is, shape is decided by angles and size is decided by the measurements of sides. This is the basic principle hidden in that. If once you understand that, it will be very easy. Now you go for it, shape must be same. Mean here what is representing shape? Angles. So whenever you are talking about similar figures, I mean especially similar polygons, their corresponding angles are equal, we can say. Corresponding angles must be equal. Then what about the sides? The sides should maintain the same ratio, that is what we call proportion. So, similar polygons means we are giving two conditions. One is they must have corresponding angles equal, and second one is corresponding sides must be in proportion. If these two conditions are satisfied, then we say they are similar polygons. Here clearly we can observe that one is connected with shape and one is connected with size. Sir, now the question is, are the two conditions important for similarity or any one condition is sufficient for polygons? Suresh sir.
So, actually equiangular figures are said to be similar. So, the corresponding angle should be equal.
Okay.
At the same time, the ratio of the sides also, corresponding sides also, it should be in proportion. Then only the shape will be as look like same.
Okay.
So, this is very important, these two. So, means the corresponding angle should be equal, at the same time the corresponding sides are in proportion. Here the very important, how to identify the corresponding sides, means that is a very important. So, the sides opposite to the equal angles, the sides opposite to the equal angles are said to be corresponding sides. So, like we have to identify the corresponding sides and we have to verify whether they are in proportion. So, these two conditions satisfies, then we can say easily those two are similar, especially in polygons.
Sridhar sir, can you elaborate it a little bit? Means my question is, for polygons, for similarity, are the two conditions important or any one condition is sufficient?
For similarity, one condition is sufficient, sir. Actually, for similarity, it look like a same, but how can we define and how can we determine those are similar? Means we have to two conditions. First, looking at it look like a same shape. After that, we have to measure that the ratio of the corresponding sides and angles. So, before that, before slide, sir, before slide, yeah. If you look, you are observing the images.
Okay.
So, one is a 16 by 3 and one is 4 by 18.
Okay.
So, in 16 by 3 also a rectangle, and 4 by 18 is also a rectangle, but both are similar or not. That means, whenever we can see the figure image, so we can see that those are not similar. Okay. Why? Because 16 is the length of the first rectangle and the 18 is the length of the second rectangle, and wherever we can see the ratio of widths,
Okay.
so those are not same.
Okay.
So it is not a, we are saying that all are having the rectangular shape and 90 degrees angles also, but same, those are not similar, we are saying. In both two figures are there, 4 by 3 and 8 by 6.
Okay.
We can see 8 by 6 is a somewhat bigger picture here, that means in a enlarged, and 4 by 3 is a smaller. So whenever we can observe those are look like a similar, but same, the different in a size, different in size. Why? Because we can say that 4 into 2, that means double. The length of the rectangle has a side double in a enlarged figure. So 8 by 4 and 6 by 3, whenever we can say the ratio of corresponding sides are equal and angles also all 90 degrees are equal. So
Okay.
angles and ratio of sides, that should be equal. The ratio of, whenever the ratio of sides and ratio of angles, corresponding angles will be equal, then we can say those are similar figures.
Okay. So both conditions are essential, that is what we can observe.
Yes.
Like corresponding angles must be equal and corresponding sides must be in proportion. For example, let us talk about rectangles. Can we say that all rectangles are similar? Is it possible? No. Why? What is the reason? It is easy to observe that for all rectangles, we can see that the angles are same, corresponding angles are same, 90 degrees only. But what about the ratio of sides? That is what Sridhar sir is explaining about that figure. Okay, look at the screen. Say here you can see that there are one rectangle and a square we are considering, suppose. There also you can see that the angles are 90 degrees. But what about the ratio of sides? Ratio of sides is not the same. L by S is not equal to B by S. So they are not similar. That's why we are saying they are non-examples. Means why they are not similar means only one condition is satisfied, but the other condition is not satisfied. Their corresponding angles are equal, but corresponding sides are not in proportion. On the other hand, suppose if we consider a rectangle and a rhombus, what happens there? You observe. And there also you can see that corresponding angles are not the same. And or if you consider a square and a rhombus also, corresponding sides are equal, but corresponding angles are not the same. They are also not similar. So whenever we talk about similarity of polygons, remember that both conditions are essential. Both conditions are essential. We can say that two geometrical polygons are similar only when their corresponding angles are equal and corresponding sides are in proportion. Yes. If these two conditions are satisfied, then only we can say that they are similar. Otherwise, they are not similar. And now, let us talk about circles. Already Sridhar sir explained about the example of a circle. And what about a circle? Here you can see that the angle at the center, if you see, for all circles it is 360 degrees. The angle formed at the center is 360 degrees. Angles are the same. And next one is size. Size means in terms of a circle it is radius. So the radii are equal for the radii are equal means they will become congruent circles, or if the radii are changing they will become similar. That's why we are saying that all circles are similar, because especially when they are keen about testing you about the similarity, these are the points where there is a scope to focus. Okay. So be clear, be confident and understand that shape, size. Once again I am stressing on those two, shape, size. Shape is decided by angles and size is decided by sides. So whenever we compare two polygons, their number of sides must be same. Then only we can say that they are similar. Okay. Likewise, suppose even if we consider two triangles, their shape is the same, but what happens? One is a right angle triangle and one is obtuse angle triangle. The angles are different, so they are not similar. Outratedly you can say. Okay. Now actually from that similar polygons we are moving towards similar triangles. Triangles is, of course, we know that it is one of the polygons, and again the same definition is applicable to triangles also. Then what makes the difference? Why for triangles we are at a later stage we are saying that only one condition is sufficient? What is the reason for that?
Yeah.
So, here I will add a point, sir.
Yes.
Actually, when we talk about congruency and similarity of triangles,
Yes.
congruency is rather easy to understand when from the children's perspective,
Okay.
because there the size and shape both have to be equal. But when it comes to similarity, at the later stage they are actually learning. For example, in our 10th class syllabus, we have many theorems about the similarity, and first we have given, right from the beginning we have given the concept, that is what is similarity and what are the parts of the triangle, and then how to compare. When we have two triangles, how to compare, what are the things that are to be compared. As you said, first of all the corresponding angles should be equal.
Yes.
Then they have to go for the sides. And as Suresh sir said, how to identify the sides, corresponding sides. Very often the children use in a confused state, like how to identify the corresponding sides. Usually they take, when you compare two figures like triangle ABC and triangle PQR, it is not necessarily that AB should be corresponding to PQ always. It may be depending on the angle which is equal.
Yes.
So, first of all we have to identify the corresponding angles, and then opposite to the corresponding angles, the sides which are opposite to the corresponding angles are to be considered as corresponding sides. So, here actually there are 6 parts of the triangle, 3 angles and 3 sides,
Yeah, exactly.
but every time we need not check all the 6 conditions.
Yes.
Based on the properties of the triangle, such as the angle sum property of the triangle, the sum of the 3 angles is 180 degrees. Similarly, there are other properties. Based on that, these 6 conditions are reduced to 3 conditions only with the help of similarity theorems. So, if the children study the similarity theorems perfectly, then it is rather easy to identify, compare and solve the problems based on the similarity.
Yes, sir. Actually, as you rightly pointed out, this similarity concept is very much familiar, and like if we have to develop that idea, then from class 8th onwards, in class 8th we have exploring geometrical figures. In those exploring geometrical figures, we can see that the scale factor will be there. Means if we ask the students to enlarge the figure or reduce the figure as per the given scale factor, that will give the idea of similarity to them. Sridhar sir, can you explain about some of the activities that are being conducted related to?
Yeah. Actually, there is some activities can be conducted in a classroom. Take a grid paper. Yeah, take on the screen you can observe that.
Yeah.
Take a grid paper and you can draw like this, the tiling what you are observing that, that is a scale up. That means 3 sides in a 3 by 3 square, that is a 3 by 3 square.
3 by 3 square.
Yeah, and we can enlarge, when we can enlarge 3 into 3, then we can draw a 9 by 9 grid. That will be the yellow color shape, that means the square, unit square is there, we can say.
Okay.
That should be also 3 times.
Okay.
Yeah, when we can draw those figure, we can observe that the center part how that will be enlarged and how it will be look like same.
How it should look like.
Yes.
Means if we give such kind of activities, then it will be easy for the students to understand.
Yes.
Then in what way they have to fill, just observe the next slide. If they fill it, it will be like this.
Like that.
So the complete 9 by 9 grid is filled.
Yes.
Okay, like see, let us see one more example. Go to the next slide. Here you can see, suppose some figure is given and it is to be scale up the pattern by factor 2.
Yes.
And how should be means we are saying that the scale must look exactly like the original pattern. At the time, in what way the child is supposed to draw that? Suresh sir, can you give any explanation for that?
Yeah. So, before your question, sir, just I want to add something.
Yeah, sure. Sir.
Already happened. in last examination, 10th class examination. So, one question was given that is based on similar triangles last that is 20th objective in the paper.
Okay.
Very simple concept. Yeah, this is because we are discussing about
Similar figures.
Similar figures,
Similar triangles.
So,
Yeah.
actually how they are going to identify. So, just it is given as a flipped model. So, actually if
Okay.
triangle ABC, if you consider triangle ABC, triangle PQR. So, here triangle ABC is said to be similar to triangle PQR if and only if angle A equal to angle P,
Yes.
angle B equal to angle Q, angle C equal to angle R.
Very good.
So,
So
this
corresponding
is,
angles.
Yeah,
Yes.
this is very, very important. As earlier we said, so the sides opposite to the equal angles are said to be corresponding angles.
Okay.
So, we have to check both. So, first
Yes.
whether the angles are equal, next the corresponding sides are in proportion, then you can say those two are similar figures. So,
Okay.
the question was given and that particular the property
Based
but
on
based on the property. So, most of them was confused. Actually the question was given wrong, like lot of comments
Okay.
happens. So, this is very important. So,
Okay.
that is the reason, as you said, you given very stress on that, for especially for these we have to consider these two, that is corresponding angles are equal and of course, the corresponding sides
sides
should
must
be
be
in
in
proportion.
proportion.
So,
Okay.
this is very, very important. So, maybe in higher classes also they may ask on the basic concept, then we have to follow that. So, that is the reason just I recall the previous things.
That is true. That is true. Okay.
One thing.
Yes, sir.
Actually, why we are discussing about the similarities? In real life, we are observing so many bridges on upon the rivers.
Okay.
And when we are constructing a railing of our house top roof, the railing will be have some pattern. So, when we are constructing houses and when we are constructing some buildings or roads or bridges, we may follow the similarity rules.
Yes.
Why? Because we are constructing, so the shape of building, how it should be, look like what are the shapes we can constructing in that. So, in real life we are having that scale factors while we are enlarging the map of world map like that. So, it look like a similar,
Okay.
right.
Okay.
When we are observing this grid,
Okay.
so that is a scale factor of 2.
Ah.
When we are scaled up, how it look like?
Yes.
So, just assume that next slide,
Next.
we can draw like that. That means 4. 2 factor means double.
So, actually here there you, again you observe what is the length in the figure, look at the screen.
Yeah.
There we have 3 is length,
Yes.
and here you can see 6 is the length in that figure which is colored. So, actually further red is occupying 1 centimeter length, means there 2 centimeters it is raised.
Yes.
And width wise it is 1 unit, means here it is doubled. The scale factor 2 means that is what you can observe. Okay. Now, actually for polygons both conditions are essential.
Yes.
Compulsory means with one condition we cannot say they are similar. But while coming to triangles, one condition is sufficient, we are saying, any one condition. What is the specialty of triangles which made them like the triangles are similar? Suresh sir, can you add anything about that?
So, actually already we discussed that equiangular triangles are similar.
Okay.
So, already that condition is given, and you, as you said that say a right angle triangle and an equilateral triangle are not similar, it is very clear, because we know that in right angle triangle one angle is 90, in an equilateral triangle all angles are
60 degrees,
60 degrees
yes,
each.
Yes.
So, by the first observation the sizes are the shapes are not same.
Okay.
So, they are not so it is very clear angles are should be corresponding angle should be equal.
Equal. Yes.
That is a very, very important.
Yes.
Okay. So, coming to this when the corresponding angles are equal, you can say those two triangles are similar.
Yes.
If you take the corresponding sides are in proportion, that's a secondary, but here very important thing is the corresponding angle should be equal. As you said previously, we show that one slide, you have taken a rectangle and a square. When you take a rectangle and a square, then it is very clear. If you take based on this what we discussed now, equiangulars means all angles are equal, then if you stick on that particular properties condition only, we can't say those are similar.
Yes,
it's very
yes.
clear, right? Square and rectangle are not similar,
yes,
because even though their corresponding angles are equal,
yes.
but it happens in triangles.
Hmm.
So, I think so this is your expected answer from
Yeah, actually what makes the major difference is like the Thales theorem or basic proportionality theorem, which is applicable only for triangles.
Yes.
That is the
Absolutely,
beauty. Like
yeah.
until and unless basic proportionality theorem is not there, even for similarity of triangles, we have to talk about both conditions. So, basic proportionality theorem is the theorem because of which what happened is some extra additional conditions are added for triangles. That is so we are going for the similarity criterion and we are proving them like theorems. Sir, what is that basic proportionality theorem, sir? Sharma garu.
Sir, basic proportionality theorem is well known as a Thales theorem also. So, it
Yes,
has
sir.
got a lot of historic background and one of the oldest theorems in mathematics.
Okay.
And in our textbook also the sequence was given very suitably, like after giving the statement only we have proved the similarity theorems.
Yes,
So,
sir.
basic proportionality theorem is very simple and it states that in a triangle, when a line is drawn parallel to one side of a triangle, then it will divide the other two sides in equal ratio.
Okay.
So, here we are talking about the ratio and the condition, the required condition to apply the basic proportionality theorem is that we need to have a line parallel to one side of the triangle.
Okay.
So, this line it intersects the other two sides at two different points, then the ratios on the other two sides will be equal.
Okay.
So, usually in the figure form, suppose if you have a triangle ABC and suppose BC is one side.
Draw the figure, sir. Draw
So,
the figure.
we are having a triangle ABC
Okay.
and the side, say for example, for the side BC a line is drawn parallel,
Okay.
say for example it is DE.
Okay.
DE is a line parallel to BC.
Okay.
Then DE divides the other two sides AB and AC in two different points, that is
Yes.
intersecting AB at D and AC at E.
Okay.
So, Thales theorem states that the ratio on AB and AC are equal, that is saying more precisely AD by DB equals to AE by EC.
Okay.
With the help of other ratios, with the help of other criteria of ratios, you can express this in different forms.
Okay.
Say for example, in reverse also is true. For example, AB by AD is equal to AC by AE.
Okay.
So, in many other ways.
Okay. So, here as you said, the first thing that we have to understand is the condition. What condition should be there so that I can apply Thales theorem or basic proportionality theorem. So, there must be one line parallel to. Here the question is like for which side it must be parallel. Is it compulsorily parallel to BC every time?
Not necessarily.
It is not compulsory. So, the line parallel can be drawn to any side.
Yes.
Okay. Accordingly, the ratios, actually here we can see 6 different types of ratios, AD by DB or DB by AD, or likewise AD by AB, AB by AD, DB by AB, AB by DB. Like this we can take the ratios in 6 different ways.
Componendo, dividendo,
Componendo, dividendo, or simply for our simple terms add one on both sides, like that we can understand that.
Yes.
Okay, those things already might have discussed in the schools also. Now, with the help of this basic proportionality theorem, we got some criterion. Criterion means actually earlier we discussed that there must be 2 conditions. For any polygon to become similar, corresponding angles must be equal and corresponding sides the ratio must be same. Proportion means equality of ratios only. So, corresponding sides are proportional, or we can say corresponding sides ratios must be same. Now, because of this basic proportionality theorem or Thales theorem, the conditions are reduced. So, any one condition is sufficient. That is what Suresh sir earlier said. Okay, first condition is what? Corresponding angles are equal. Corresponding angles are equal condition is sufficient. That is what we are calling criterion A criterion for similarity. When in 2 triangles angles are equal, that is what we call them equiangular triangles. That is how equiangular triangles are always similar, we are saying. Equiangular triangles are always similar. Because what is the criteria there? AAA criterion for similarity is applied.
Yeah, actually, sir, Sharma sir,
Yes, sir.
you said the beauty of the geometry of similar triangles. So, this is a very, very important.
Okay.
So, the teacher has to explain the beauty essence of the particular concept in the classroom, then only the children can enjoy the learning process.
Yes.
Here you just by if the children by heart the concept, simply the corresponding angles are equal and corresponding sides are in proportion, the two triangles are said to be similar. If the children by heart it, then there is no use, after some time they will forget. So, now by you explain the link, how the basic proportionality theorem is connected with the similarity,
Yes.
and how it is proved. All these things are interrelated, that nothing but you can say amalgam of all these concepts.
Yes, sir.
So, you said that beauty, this is very, very important. As you discussed right now in this session, so teachers also they have to explain. So, see AD by AB, like so many ratios, nearly 6 ratios. All these ratios are not compulsory, these are derived ratios
Yes.
from the two triangles, triangle ABC and triangle AD, which are similar to each other. So, like we have to explain, then the children will not feel a similar triangle concept or any other parts of geometry difficult. So, we have to explain the essence or the beauty of the concept or the key concept, particularly in a elaborated explanation, then definitely we can enjoy the learning of geometry.
Excellent.
Yes, we have some material in our schools also. That means we can visualize, we can give the experimental experience to the children by use purchase.
Yes,
but take one two strands and we make one equilateral triangle or some isosceles triangle, whatever it may be,
Yes.
and put a thread in parallel to one side, and when we move that, the scale will be same. That means the
ratios,
the
we can
ratios of
observe.
the other side should be divided into the same ratio.
Yes.
So, that should be the visualization and experiential learning should be there in a classroom. We have to provide.
Actually, sir, you rightly pointed out, even we can take the help of some ruled paper,
Yes.
and we can ask the students to draw the triangles.
Yeah.
And we can observe how many lines are there, we can count and we can observe the ratios. That is a simple. So, actually giving an activity is more important.
Yes.
So, instead of giving it like a rule, that this must be true, this must be true. If we explain them the basic ideology, if the concept is built in the mind of the child, then it will be easy for them to, and once it is settled in their mind, that is why earlier also we have shown some grids like scale up, scale down. These are all like creating the conceptual idea in the young minds, so that it will be easy for them to understand how the similarity will expand. Okay, how the similarity will diminish or reduce the figure, in what way it applies, what happens to the area, these are all interlinked. So, when we are doing one activity, we have to put some more questions related to that, so that they will understand it better. And further, if we observe, some constructions are also there.
Yeah.
Actually, behind the constructions also these basic proportionality theorem principles are applicable. But we mechanically give the procedures like, okay, do this and like with compass draw arcs and all. But why it is how basic proportionality theorem is applicable there? If we explain them, the children will understand and appreciate the beauty of mathematics.
Yeah, actually, the scale factor also, just now you brought that slide is an excellent slide. To all the teachers will understand what is the scale factor.
Next one.
What is the scale factor? Simply scale factor we are using. Why the scale factor? Okay, in the examination 3 by 5 or 5 by 3 or something will be given, that will be considered a scale factor. So, if the scale factor is a proper fraction, the triangle comes inside, the scale factor is a improper fraction, comes outside, like we are learning the concept. Am I correct or not? But actually, if you show that, as the slides are shown in this session. So, if you show that information to the children can understand what is the scale factor, how the scale factor connected with the similarity, then they can use the construction, they can understand. So, mostly the same question even some children are asked me in the classroom also. So, why you are using the scale factor? So, we have to answer by you explaining all these things. So, this is very important. You can use this slides of course, the concept in the classroom transaction before going to explain the construction question. Then children can understand the scale factor. Then after the understanding the scale factor, now you can use a construction. That is my opinion.
Excellent.
Sir, I will add one more point, sir.
Yeah, sure, sir.
Like as you said, the burden on the children in learning these concepts is increasing because they are trying to go on for rote memory type. Instead of that, if the children and the teachers together solve all the problems given in the exercise or examples or maybe any other reference book based on a theorem. For example, in our textbook is well organized. Say for example, immediately after Thales theorem, one exercise is there where all the questions related to Thales theorem are given.
Yes.
So, if the children solve all the questions, then they will understand various situations where this Thales theorem is applied. So, in that case they need not remember always that AD by dV is equal to AE by EC.
Yes.
That burden will be reduced, and moreover they can see, they can practically see what are the various situations where the theorem is applicable. As soon as they look at the figure, where is the parallel line, which ratios are equal, what are the corresponding sides, what are the corresponding angles, all these things can be well understood only when they solve the problems.
Yes.
And this can be applied to real life situations also.
Yes, sir. Right. So, actually here further if we observe for basic proportionality theorem, we are saying that a line must be drawn parallel to one of the sides. Yes. Then that line divides the other two sides in the same ratio, means the given condition is parallel line and the ratios are equally is the result like RTP. On the other hand, if suppose the ratios are equal, the line will become parallel, that is converse of BPT. Actually, when should we apply BPT and when should we apply converse? That depends upon the given conditions. So, what is the given condition? Whether we are given a parallel line or we are given the measurements and we are observing that the ratios are equal, that is why you can say parallel. Parallel line is given means ratios are equal. On the other hand, if suppose ratios are equal, we can say the line is parallel. Okay. Based on that, I think we discussed about the criterion like AAA criterion for similarity. Of course, we know that for triangles, angle sum property is there, that is why AA similarity is more than sufficient, we are saying. And then corresponding angles. Likewise, if you talk about corresponding sides, only if that condition is sufficient, that is why we have SSS criterion for similarity. Means based only first condition is sufficient, AAA criterion, and its corollary is AA, because angle sum property is applicable, no need of all the three angles. If two angles are equal, third angles will be definitely equal in both the triangles. And likewise, we have SSS criterion for similarity, and apart from these two, we have one more, that is SAS criterion for similarity. Like this, we have different criterion, right? AAA criterion, SSS criterion, SAS, and of course, for right angle triangles, it is RHS criterion for similarity. And in what way it will be helpful to the students means, actually if you observe the textbooks, the first instance itself, it is started with one situation in the day to day life. Like one girl is asking like how to find the height of a tree. So, with that the textbook introduction itself, one problem is given connected with the day to day life situation. For that a mirror is placed in the middle and the triangles are formed. So, actually there are different ways for finding the height of a tree using the shadows. Actually ancient mathematicians used the same technique for finding the height of a pyramid, and for finding like the boat, like at what distance it is from the shore. All these things are connected with similarity. Okay. Remember that no concept is just like that, it is developed in their day to day life. Whenever they come across a problem like finding the height of a pyramid is a challenging question in those days. To overcome that challenge, they developed one mechanism, that is with the help of these similar triangles, they used a meter stick and they kept it and they measured the length of the shadow and they measured, and that is how they found, right. So, after the criterion, actually before going for the applications, areas. Sridhar sir, can you explain like what type of or what sort of activities are helpful for the teachers to well explain the concept of areas?
Yeah. So, see on the screen, we are observing the similar polygons.
Okay.
So, this is two rectangles combined with a L shaped. So, in first figure, how many squares occupied in that? So, 1, 2, 3, 4, 5, 6 square units, and in second one the area 24 squares, 24 unit squares are occupied in the second shape. So, when we observe the length and width, that means corresponding sides. So, when we observe the corresponding sides, the length of the first figure is how many 1, 2, 3, 4 units, and length of the second figure is that. How many sides are there? 6 is there. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 8. So, this is the 1, 2, 3, 4 units. This is the first figure is 4 units and second figure is 8 units. That means double.
Okay.
Right? When we can observe the width, this will be here. So, this is the 3 units. This is 3 units. And when we are observing this 1, 2, 3, 4, 5, 6, this is also double. That means corresponding sides, the ratio of corresponding sides are in proportion.
Okay, so 3 is to 6 we can take.
When we are observing that area, how the area will be increased, how area will be increased. So, here 6 and here 4, when we are proportional with a factor 2, then the area will be the square of 2, that means 4 times.
4 times, okay.
So, we are given the generalization, so many experimentation, so many hands-on experience, the children can generalize that the ratio of areas of given similar polygons, that should be the ratio of the square of the sides of the ratio.
Okay.
So, we can observe the next figure. See, whenever we move to triangles, so the area of first figure, first triangle, so the area of first triangle is 2 square units. How can we calculate? You know that. That means a full square and 1/2 squares. So, this is the height is at 2 squares and base is 2 by 1 half into 2 into 2, that means 2 square units.
Okay.
Right? Whenever we move to the second triangle, when we move to second triangle, how many is this is here it is 2 units, and how many the scale factor will be there? 1, 2, 3, 4, 5, 6. It will be 3. So, 3 times. So, base also here 2, these are 3 times. So, whenever the corresponding sides of the ratio of the corresponding sides will be 3, that is the square that equals to the area of those figures, area.
Okay.
So, we can generalize that the sides of the ratio of the sides total square of the lump sum quantity that equals to the area.
Yeah, you can say simply the ratio of areas of similar figures is equal to the ratio of squares of corresponding sides. So, we can generalize the
okay, of course, if we extend the same a little bit, we can say volumes is
exactly
for the cube ratio of sides of the whole to the power of 3. Right. Then actually further if we observe the famous Pythagoras theorem, or actually it is 𝗏𝗏 theorem and known as Pythagoras theorem. What is the statement of Pythagoras theorem, and in what way similarity is helpful in understanding this Pythagoras theorem? Suresh Garu.
So, actually if you want to say about geometry, everyone will say whether they aware about the geometry or not, but they will ask as a Pythagoras theorem. Such a familiar theorem it is. Actually, it is about our theorem. Familiarized as a Pythagoras theorem, on the name of Pythagoras, it was as a Pythagoras theorem. Anyway, the Pythagoras theorem is very simple. Not only we use in mathematics, we will use this in all branches of sciences also. So, if you take a right angle triangle, the square of the hypotenuse is equal to the sum of squares of other 2 sides. So, actually this is the Pythagoras theorem. So, and we can prove the Pythagoras theorem in several methods, as you
just look at the screen.
Yes. So, when you see the screen, there is a very clear. So, there is a proof of Pythagoras theorem. We can prove that Pythagoras theorem easily. If you construct some squares on each side, of the right angle triangle, the area of the square on the hypotenuse is equal to the area of the sum of the areas of the squares on the other two sides. Like nearly more than 106 proofs are there, everyone knows this information. So, this is a, I think so, in my knowledge it is a one of the theorem which has the maximum number of proofs. And we can prove by using similarity concept also. Just observe that a screen how we can prove the Pythagoras theorem. Yeah.
The dimensions are changing.
So
Okay,
many
actually we can see that they
Yeah.
are congruent and like
exact. So many theoretical proofs are there, but
Okay.
when our child will understand the experimentation only, they will understand. So let them draw a right angle triangle on the grid paper, and they have to make a squares
Okay.
equal to the sides, and they calculate the areas of those areas of the squares, small
Yes.
squares, and the hypotenuse of the square prepared
Yeah.
by hypotenuse.
Yes.
So let them understand how it will be. So that will be more effective in our classroom.
Yeah, actually as you said ratio of squares means actually geometrical idea is you construct a square on that side. Okay, the square constructed on the two sides is equal to the area of the square that is constructed on the hypotenuse. That is what it says actually.
Yes.
Okay. So that's so the Pythagoras theorem, of course we, as we said, we have different proofs like cross sectional methods are there, and based on that you can see this extension, this Pythagoras theorem is helpful in circles also.
Yes.
And before going further, let us talk about the similarity of triangles, like using shadows. What sort of problems can be given? Just let us look at the screen. And we have different types of problems related to the shadows of triangles. Like using the shadows, we can find the heights of trees, heights of temples, and so on. Okay. In what way we can, like, what are the different things? Like this is one of the problems. Like
Yes.
in what way we are going to find the height of that lamp post? So actually we ask one of the students to stand there, right? So his shadow must coincide with the shadow of the lamp post. Okay, in such a manner he has to stand. Then we can measure the length of that person, we can measure the length of the shadow, and actually the length of the, means there we can see that there are two right angle triangles. Two right angle triangles are formed there. Yes, sir. Sridhar sir, would you like to add anything to that?
Yeah, actually when we are observing those slides,
Okay.
so all are we are applicable for, we are applying for that right angle triangles.
Yes.
So we are how when we have the height and the base and angle, we can use Pythagoras, we can use directly the trigonometry also. So one concept to one concept internal relation is there. When we are moving to similar triangles, how the person will change their position, how the person will change his position, how the similar triangles are formed, and how in what ratio the sides are dividing. So those applications should be understood by the children.
Yeah, actually as you rightly pointed out, okay, finding the height of a tree means we can find the height using similar triangles using trigonometry.
Yes.
So what is the major difference? Suresh sir, can you explain?
Yeah, if you take it as a trigonometry application of trigonometry, there we are not using any similar triangle concept, just we are using that trigonometric ratio property. So
Okay.
by using that we can find the height of the tree or height of the pole, whatever it may be. But it is here we will prepare two similar triangles, and by using the similar triangle concept we will find a corresponding side measurement. So here, so we are using here the property of the similar triangles.
Yes.
So the corresponding sides are in proportion. So by that property we are finding the unknown value.
Yeah,
That's the
unknown
difference between the
Yeah,
two different
actually, as you rightly pointed out, in case of similar triangles, no need to measure any angle. Simply speaking, no need to measure any angles. Just we measure the length of the shadows, height of the person, and by taking the ratios, we can find the height of the tree or building or so. Okay, while coming to trigonometry, we have to measure the angle. So trigonometry gives the relation between the sides depending upon the angle. It is somehow or the other connected with that. Okay, so not only this, we have different types of problems related to this. Just look at the screen once again. Here, there also you can see two right angle triangles because the sun's rays are parallel.
Yes.
Those angles are equal, so corresponding angles are equal. So those two triangles are similar. AA similarity is clearly used here. See, in most of the problems, the same thing will continue. Like two triangles similarity. Like one more slide, next. So these are all more or less the same sort of things. Like here also you can see a person is standing a tree. Okay, we can place a person and we can find his height and the length of his shadow and the shadow of the tree, by which we can find the height of the tree. Actually, even we can take a meter stick, as we said, we can take a meter stick and we can find. These are all different ways for finding the height using shadows. These are all simple techniques. Like the basic idea behind all these things. As I said, here you can see a meter stick is used here. So what can be measured? Meter stick means its length is 1 meter. We can measure the shadow of the meter stick and shadow of the tree. Then with the help of that, we can find the height of the tree.
Yes.
Okay. So these are all the daily life applications of similarity. We can see in most of the occasions it is used. Actually, as I said, there are different challenges in the day to day life, and to overcome that, the idea of similarity is developed. And now this, in what way we connect this Pythagoras theorem to circles?
Yes. Actually, one point we are forgetting that.
You
Why?
want to
Because
add?
when we are moving to trigonometry, the sine theta, cos theta, tan theta, when we are doing the ratios of trigonometric values, how they are evaluated? They are using the
Similar triangles concept only.
Similarity rule only.
Yes.
So when we are developing one concept to another concept, when from ancient to modern mathematics, those are helpful to the all similarity rules. Euclidean geometry is have keeping a very key role in the geometry.
Yes, that is true.
We cannot forget the Euclidean.
Yeah, actually here not only this, sir, if you further observe, like we talk about coordinate geometry.
Yes.
That is also the application of geometry. Okay, we are studying geometry in terms of algebra.
Yeah.
Right? That's why you can see whenever you talk about the section formula,
yes,
there again we are taking the help of similar triangles concept. So similar triangles, congruent triangle, these are the key ideas, and wherever we have to study further, definitely you need to understand the three-dimensional geometry, coordinate geometry at a later stage. You need the help of Euclidean geometry because it is the base. You rightly pointed out that.
And one more thing is see on the screen, when we are drawing one pair of tangents to a circle one from external side.
Okay.
So when we are moving that point of tangent, that point of this one.
Point of contact.
Point of contact. The radius will be always it will be 90 degrees.
Okay.
So when we draw at this one, it look like a rectangle, a right angle triangle.
Okay.
So when we have the right angle triangle, we can move to Pythagoras theorem. While the finding the length of the tangent, find the length of the radius, the distance between the external point to the center of the circle. So we can use simply to solve to the Pythagoras theorem we are using.
Okay.
So Pythagoras theorem is very, very important in our geometry, where the right angle triangle, when we have see the right angle triangle, we immediately we have to recall the Pythagoras theorem.
Yeah, as Sridhar sir said, so here you have to understand the construction of the textbook and the philosophy of the textbook. See how the chapters are arranged.
Okay.
So there is a very beauty in that. If you know that, we can enjoy that beauty. See, if you know Pythagoras theorem very well, an application of Pythagoras very well, then we can understand maximum concepts of tangents and secants of a circle. Then you can extend to the trigonometry chapter. If you want to know all trigonometric ratios, first you have to understand the similarity triangle concepts. So, that is the reason that similarity is given first, then trigonometry is given next. So, like if you discuss in the classroom, if you feel that, so this is the actual thing behind the arrangement of the chapters, then we can enjoy the textbook
and
clearly.
one more thing, sir, and not only the similarity is for this only, not only for this geometry, for 10th class and 9th class, in a lower classes also we are discussing in the symmetrical objects.
Yes.
In symmetry also, we can find the very beautiful objects in our nature have a symmetrical objects, all our objects symmetrical, then we can draw the similar triangles for that. So, when we use a isosceles triangle is a one block, we can make so many designs, so many beautiful designs.
Okay.
When we constructing the bridges and
it
we
is
construct
like
the
a
railings,
pattern
so many patterns, so many patterns we can construct.
Okay, sir. Thank you. So, here easily we can observe that like as they rightly pointed out, congruency means mainly in class 8 we already discussed reflection, translation, rotation. These three types of transformations will preserve congruency and its properties, and further we know that congruency is a part and parcel of similarity, not a separate one. In similarity we have three types of things: enlarged figures, equivalent figures and reduced figures. Okay, equivalent figures is identical figures, that is what we can say congruent figures, and enlarged means the image will be larger, and reduced means the image will be smaller. So, basically whenever you study any chapter, you understand what is the concept, what is the link, in what way it is helpful in understanding the other concepts. If we go in that sequence, then you really start enjoying mathematics. Okay. So, that is all for today. Thank you. Thank you very much. We will meet with some other topic in our next session. Thank you.